Okay, moving on to problem 4. A certain transformer has 500 turns on the primary. If 10 volts are applied to the primary, how many turns must the secondary have to produce 60 volts? If the current in the secondary is 1 amp, what is the current in the primary? Okay, so real quick, let's just draw a little doodle of our transformer. So here we have the primary, which has so many turns, and the secondary, which also has so many turns. So now we know that the voltage, the potential difference across the primary is going to be V1 is equal to 10 volts, and that the number of turns it has, N1, is equal to 500. In the other case, we want the potential across it to be 60 volts, and we want to know how many turns we need to make this happen, right? And so if we remember from lecture, the equation that related the voltage and turns between the primary and secondary of a transformer is V1 over N1 is equal to V2 over N2. So in this case, we're looking for N2, so we're going to multiply it to the other side and divide V1 over N1 to the other side, which is going to leave us with the equation N2 is equal to V2 times N1 over V1. And here we can just plug and chug. So we're going to have 60 volts times N1, which is 500, divided by V1, which is 10 volts. So doing some quick math, we find out that N2, the number of turns in the secondary, has to be equal to 3,000. Okay, so that's the answer to the first one, or first part of the problem. For the second part, if the current in the secondary is 1 amp, what was the current in the primary? So that means, right, we now know V2, right, we know is 60 volts, and we know I2, the current through the secondary, is 1 amp. As well, we know V1 is 10 volts, and now we want to know what the current in the primary is. Question mark. So in this case, what we want to remember is the quintessential energy cannot be created or destroyed, conservation of energy, right? Which means the power that goes into the primary is the same power coming out of the secondary. So we can use the equation P1 is equal to P2, and then the equation P is equal to IV for both of these to solve for I1. So that's what we're going to do. So here we have I1 V1 is equal to I2 V2. Divide both sides by V1, and we're left with I1 is equal to I2 V2 all over V1. So that's going to be 1 amp times 60 volts divided by 10 volts. Volts cancel, and we're left with I1 is equal to 6 amps. And that's the current that the primary will have, so that the power in is the same as the power out. Okay, so that does it for problem 4.